All right. So right now what we're going to do is a workshop on two things, amplitude and period. Both very important things to know for a wave. Period, remember, is how long it takes for one full cycle. Amplitude means how high the wave is. So what I'm going to do is I'm going to connect this to the project first. Actually, I should take a break. Connect it to the project first. Then I'm going to teach you a couple of things that we need to know in order to actually complete some things for our waves. And you're going to practice some problems for me. Okay? So first things first. You all have chosen some values for your waves. You have chosen a height. You have chosen a wavelength, which we represent with the Greek letter lambda. So this means wavelength. Technically, that's the Greek letter lambda. And you also have chosen a depth. A depth. So here's what we need to make sure of first. I'm going to tell you some information about your choices for these numbers to make sure those choices are correct choices. If your wave was created by an earthquake, your height should be between 10 and 20 meters unless you are modeling a wave that already happened and you found a different height. It should be between 10 and 20 meters. Your wavelength, if you have an earthquake, should be between 100 and 300 miles, whatever meters that is. The depth, I'm going to trust that you just found a depth that is appropriate. Okay? Because it really depends on where you are in the ocean, so I'm just going to trust that that's a good choice. If your wave, was created by a landslide or a volcano, for a landslide, your height is going to be actually pretty tall, like 100 to 200 feet, whatever meters that is. Your wavelength is actually going to be a lot shorter. It's only going to be a couple hundred meters. And then your depth is probably going to be very small because if it's a landslide, it's happening right at the edge of the ocean, so it's not going to be too deep. If it's an underwater landslide, that's a little bit different. So if you chose an underwater landslide, you want me to double check it, and let me know. Lastly, volcanic eruptions. Your height is going to be a little bit taller, so it'll probably be between 10 and 50 meters, I'd say. Your wavelength is going to be less than a mile, so however many meters that is. And then again, your depth is depending on if your volcano is very bottom, the most deep part of the ocean, or if it's relatively close to the top.
Do you know anything about like what ice is?
Ice would be the same as like a landslide. So it would be between like 100 and 200 feet for the height. It would be a short wavelength, a couple hundred meters, and then it would be a, the depth would be depending on where the ice actually is.
Okay.
All right, so using this information here, let's go ahead and talk about two things, amplitude and period. And we're going to talk about them with respect to this equation, A times the sine of Bx plus C plus D. All right. Think, with our last project for carbon dating, what did our amplitude represent?
The starting value?
Starting value. Do we know a starting value for our wave? Yeah, it's the height that you chose. So in this case, my big A is going to be whatever your height is. If my wave is 10 meters tall, it's 10. If my wave is 20 meters tall, that's going to be 20. Fairly easy. Okay. So A is amplitude, right? And that's our starting height. Now, period is a little bit more difficult. That's why we're doing this workshop. We have two definitions of period. We have a physics definition, and we're going to create a math definition. Does anyone remember the physics definition of period? T equals...
Like the full cycle?
So it's the time it takes for one full cycle.
And then from there...
And with respect to an equation is what I'm looking for here. It's 1 over F. That's what I was getting at. Thank you. But it's the time it takes for one full cycle. Okay? Now in math, I'm going to have another definition. It's going to be 2 pi divided by b. Why is 2 pi a familiar number to us? Yeah, that's one full rotation of the unit circle. Perfect. B is a number being multiplied by the x. So with respect to transformations, it's not going to shift it left and right. What's it going to do? Stretch it or shrink it. Okay? So what this is doing is saying, okay, my normal cycle of a wave is 2 pi radians. This b value, bless you, is going to change that, right? It's going to shrink it, or it's going to stretch it. I need to figure out how. So what we're going to do is use an example here on those papers I gave you, problem number 1, to try to understand these things. Number 1 says f of x equals the sine of 4x, and I want to know the amplitude and period. Oh, hey, right here. Pass these back, please. All right. What is the amplitude equal to?
Is it 1?
1. Perfect. There's no number in front, so it's a 1. Period. What is my b value? 4. So if I use that equation, 2 pi divided by b, that's really like 2 pi divided by 4, which reduces down to pi over 2. So I want you to understand the meaning of this. That means that instead of it taking 2 pi radians for the entire rotation, it only takes pi over 2 radians. So here's a really great, easy way to graph this situation. I'm going to do it right here so you can see the comparison. Pi over 2 is less than 2 pi. So let's see what that does. Remember back to creating this wave, we use the unit circle, right? We have 4 sections. I go to pi over 2, I go to pi, I go to 3 pi over 2, and I'm back to 2 pi. There's 4 sections of a wave. This number tells me how long it takes to get one full rotation, which means I have to take that and split it into 4 sections. So I'm going to look at this distance, starting, ending. Pi over 2 is my period. I'm going to split it into 4 equal sections, which I could calculate relatively easily if I needed to. And I'm now going to graph my wave. Remember with sine wave, when we did it together, everyone last semester, I was like, okay, it's always max, x-intercept, min, x-intercept. So max, x-intercept, min, x-intercept. I've now graphed my wave. What has happened to it?
It's horizontal shrink.
Horizontal shrink. So in general here, if you have a number in front of that x and that number is greater than 1, what does it do? Shrinks it. Remember, x is always opposite of what you think. It shrinks it by a factor of 4. And we can see that visibly right here. All right. Okay with that so far?
Yeah.
Yeah. Right now, we're breaking this down, people. So I don't care about shifts left and right. I don't care about shifts up and down. I care about amplitude and period. All the problems on this paper you're going to do for me in a little bit are just amplitude and period. Now, second piece. Here's the equation we've identified, we've graphed. Now I'm going to give you a graph, and I want you to find the equation. So this is the last part of this workshop, and we're done. Let's say I give you the following. I have a wave that goes up to 6 and it goes down to -6. Let's say that the period is 3 pi over 4, and let's say that it looks like the following. And I want to find the equation of this wave using amplitude and period. Okay, first, what has changed from this wave to that wave?
It's split.
Yeah, it's been reflected. So my amplitude is what kind of number?
Negative.
Negative. Yeah. Now, what is the value of my amplitude?
-6.
6. So that means if I'm writing the amplitude of my equation, I have -6. Right? 6 represents the distance between the equilibrium and the crest, or the distance from the equilibrium to the trough. Thank you so much for doing that. I appreciate it. So notice, in physics, amplitude is really like a distance, so it's always positive. So in math, I think of my amplitude as an absolute value when I talk about how high the wave goes from the equilibrium or how low the wave goes from the equilibrium. Make sense? Cool. Awesome. Now, the next part is finding out my b value. Well, I have a formula. For the love, let's just use the formula. My period is 2 pi divided by b. What is my period of this wave? 3 pi over 4. So I have 3 pi over 4 equals 2 pi over b. cross multiply here. So 8 pi is equal to 3 pi times b. Notice I'm not using a calculator because that's going to make things messy. It's going to give you decimal approximations. To get rid of the 3 pi, I do what to both sides? Divide. Pi's cancel out. My b is 8/3. Done. Okay. Questions before we sum everything together? Almost done. All right. So here's what we've done. We now know what things we have about our wave. Your waves probably are not going to have a height of 1, which means it's important to understand amplitude. Your waves probably are not going to have a period of 2 pi because they're super far apart. So it's really important to understand this concept of that number right there, which stretches or shrinks. After you are done following the directions on Echo for the number of problems you have to do on this activity, you're going to come back to me, and I'm going to teach you now how we can apply it to find the amplitude and period of your wave. Make sense? Yeah. Good. Take a break. Take a 5-minute break, because you guys didn't take one yet, and then come back and start working. Good.